In this video, I'm going to talk about solving square root equations. So we've got a first little example here. So typically when we're solving equations, we want to isolate the variable for which we're solving. So this x is my only unknown, so I want to solve for this x. But right now he's kind of trapped underneath this square root, so how can I get rid of the radical? Well, I can square a radical, and that will take care of it. So I'm going to use the squaring property of equality here and just square both sides. So over here, the square and the square root cancel, which kind of releases that x minus 11, so he's no longer bound by that radical. And then 4 squared is going to be 16. Well, hey, this looks like a really nice one-step equation. I'm just going to add 11 to both sides, and I'm going to get x equals 27. Hey. Okay, and I will say one thing about these square root equations, that values that you get for your solution, you always have to check them. Because a lot of times you're going to get extraneous solutions. An extraneous solution just means when you solve the equation, it's one of the values you got for the answer, but when you plug it back in, it does not work. So this x equals 27. So 27 minus 11 is 16. The square root of 16 is 4. So we know we're okay, so the answer to the first one is x equals 27. In the second example, I have the cubed root of the quantity y minus 3, and we're going to say that equals 2. So again, we have this variable, and we need to isolate it. So right now it's trapped underneath this cubed root. So the opposite of the cubed root would be cubing. So I'm going to cube both sides, and this cube and the cube root cancel each other out. So I have y minus 3 equals 2 cubed, which is 8. So then when I just add 3 to both sides, I get y equals 11. But like I mentioned before, you always need to plug your values in to see if they work out. So 11 minus 3 is 8, and the cubed root of 8 is 2. Yeah. So that one works out again just fine. In my third example, I have the square root of the quantity, x plus 56, equals x. So I don't have just a number by itself over on the right side. I actually have variables in two places. But I still want to release this variable from the radical, so I'm still going to do the opposite of the square root and square both sides. So the square and the square root will cancel each other out. So I get x plus 56 equals x squared. Well now it seems like I have a quadratic equation to solve. So I want to put all the terms on the side of my x squared. So I'll say 0 equals x squared minus x minus 56. When I just positive x over here makes it negative. Positive 56 moves it over here makes it negative. So I wonder if I have to use the quadratic formula or if I'm able to factor this. Let's try factoring first. So x and factors of 56 that are 1 apart. Or we're going to say two numbers that multiply to make 56 that add to make negative 1. Looks like negative 8 and positive 7. So when I set each one of those independently equal to 0, I'll get x equals 8 and x equals negative 7. And I think this might be the first example where we see what extraneous solutions are. Okay, so I'll rewrite the original right here. So we have x plus 56 equals x. So if we plug in 8, 8 plus 56 is 64, and the square root of 64 is 8, which 8 was divided for x. So actually 8 will work out. Let's try negative 7. Negative 7 plus 56 is 49. The square root of 49 is 7. Oh, but our x was negative 7. So actually negative 7 will be extraneous. So our only solution is x equals 8. So you have to watch out for values that when you solve it you might get, but actually when you plug it back in they will not work. And again, those are called extraneous solutions. In our next example, we have the square root of the quantity x plus 18 equals x minus 2. So this looks a little bit like our previous example where there's multiple variables, but x over here is not by itself. It will not, however, affect the way we solve it. We'll start by squaring each side. So my square and my square root cancel each other out. So x plus 18 now equals Well, this x minus 2 quantity squared, remember when you square a quantity, you got to put them next to each other here. So I'll actually have to FOIL this out. And I'll get x squared minus 4x plus 4. Now I have this quadratic equation where I have terms all over the place. So I want to get them all on the same side where my x squared is positive. So my x squared is positive on the right side. When I move this x over, it'll be negative x, so negative 5x. When I move this 18 over, it'll be negative, so negative 18 will be negative 14. Okay, so I always look to see if I can factor this first. So x and x. Factors of negative 14 that add to negative 5. Hey, well, I think negative 7 and positive 2. Well, like we did before, I can take each one of these factors independently and solve. So I'll get x is 7 and x is negative 2. But you have to be careful because you might have extraneous solutions. So here's my original problem right here. Let's try plugging in 7. 7 plus 18 is 25, and the square root of 25 is 5. And 7 minus 2 is 5. So my 7 works. Okay, let's try my negative 2. Negative 2 plus 18 is 16. Square root of 16 is 4. And then negative 2 minus 2 is, negative 4. So no good on that one. So again, we have an extraneous solution. So the only value that works for us is this one, x equals 7. In my next example, it looks like I have two radicals here. I have the square root of the quantity x plus 6 minus the square root of the quantity 2x minus 4. Well, if I was to square both sides right now, I'd have to FOIL this out, and I would still have radicals left over. So very bad. So I'm going to add the square root of 2x minus 4 to both sides first. The idea is putting this over there. So I have the square root of the quantity x plus 6 equals the square root of the quantity 2x minus 4. Well, okay. Well, let's see. When we square both sides now, all the radicals will go away. So I just have x plus 6 equals 2x minus 4. So when I add 4 to both sides and minus x from both sides, my 4's cancel, my x's cancel, and I have 10 equals x. Well, just like we've been saying, let's go ahead and plug this back in. So 10 plus 6 is 16, square root of 16 is 4, minus 2 times 10 is 20, minus 4 is 16, square root of 16 is 4. So 4 minus 4 equals 0, very true. So my x equals 10 solution is correct. In this final example, we're going to have a little bit of fun and do kind of a good problem here. So it's already set up nicely for us, so we're just going to square both sides to get rid of our radical. Okay, so the square and the square root cancel, so we have 15x plus 10. And then, of course, since this quantity is squared, I need to FOIL it out. So 4x squared plus 12x plus 9. Okay, so I'm going to subtract 15x from both sides. Also subtract 10 from both sides. So I'll have 0 equals 4x squared minus 3x minus 1. Well, there's lots of ways you can factor this. Factor by grouping, like using the AC method, or maybe guess and check or something. So I'm going to rewrite it and use the AC method as minus 4x plus x minus 1. And then factor by group and take a 4x out, x minus 1, x minus 1. If you're not sure how to do this or what I'm doing, you can always check out the video for the AC method and factor by grouping. So it'll be 4x plus 1 and x minus 1. So we'll say 4x plus 1 equals 0, x minus 1 equals 0. So this will yield x equals negative 1/4, and this will yield x equals 1. Okay, but to this point, some of our equations have yielded extraneous solutions, so we need to go ahead and check both of these. I'll check the 1 first, because he's just a 1 and he's pretty easy. So 15 times 1 is 15. Plus 10 is 25. So the square root of 25 is 5. So I'll put a little 5 up there. 2 times 1 is 2. Plus 3 is 5. So 5 equals 5. Hey! So my 1 works out. I don't know, so maybe my negative 1/4 won't work? I don't know, let's see. I'm going to rewrite my problem down here. So square root of 15x plus 10 equals 2x minus 3. I rewrote it because sometimes doing these fractions takes some space. So 15 times negative 1/4 plus 10. Well, 15 times negative 1/4 will be negative 15 over 4. My 10 is over 1, so I can multiply the top and bottom by 4 to get plus 40 over 4. It's the square root of all that business. So negative 15 plus 40 is 25 over 4. And the square root of 25 over 4 is the square root of 25 over the square root of 4. Okay, that's kind of a mess over there. Well, maybe this right side will work, maybe it won't, who knows. So times 2 times negative 1/4 minus 3. Okay, so negative 1/2 minus 3. I get negative 7/2 when I work that out. So 5/2 is not equal to negative 7/2. So this actually, negative 1/4 will not work, so x equals 1 is my only solution.